Okay, so let's move on with the remaining parts of this in-class portion of the computer assignment, and let's go down to looking at questions that require the use of a two-way ANOVA. So question 8 says, are there differences in the extent to which the child views teenage sexual activity as acceptable, which is the same variable we've been using, sex okay, at baseline, as a function of the importance of religion to that child, religious importance, and whether or not there's a male adult in the household, male in the house. And if you look at the data for religious importance and for male in the household, you can see that religious importance is coded, it looks like from 1 to 4. We can go over here and take an actual look at it in the variable view. Religious importance. Here are the values. And then if we also look at whether or not there's a male in the household, you can see that it's also a categorical variable with just values of 1 and 2. So religious importance and male in the household are both categorical variables, and the sex is okay variable is a continuous variable. So because we're looking at two independent variables at the same time, we have to use a two-way analysis of variance. So to do this, we go where we've been going before to a univariate, because they're all between subjects variables, univariate analysis, and we're looking at this same variable, sex okay at time 1, and we're looking at it as a function of religious importance, which we consider a fixed factor, and whether or not there's a male in the household, which we also consider a fixed factor. Now, anytime I have two or more independent variables, I really like to get a plot. It just helps me to kind of see what's happening. And I will typically put whichever variable has the most levels on the horizontal axis. It just makes it easier to look at. It's better to have fewer lines. For me, it makes it easier. Add that variable there and hit continue. Then under options, I'm going to want to see the means for everything. And I'm going to want to have effect size in case anything turns out to be significant. And then I'll probably come over here, since they're all between subjects variables, and get the post hoc tests for the main effects from this screen here. Okay, so then I'm going to paste that into my syntax window. I'm going to highlight it and run it. Oh, nice. I got this nice message from the computer telling me that it didn't run any post hocs for male in the household because there are fewer than 3 groups. Well, of course, that makes sense. I wasn't thinking. So that's great news that the computer tells me that. So with this tells us some of our ends. You can see that in terms of the how important is religion to you variable, it's not very evenly distributed, and that's something that you would want to think about. These small cells here could impact whether or not you get significant results. Sometimes what people will do is they might recode that variable so that maybe not or slightly and moderately were together. That doesn't help you a lot. Maybe all 3 of these are together, and you compare people for whom religion is very important to everybody else. So that might be a way to handle that. And these numbers are pretty even, so that's good. Okay, so we look at the test of between subjects effects. And in this case, because it's a two-way ANOVA, we're going to be looking for 2 main effects, the main effect for religious importance and having a male in the household, and then also this interaction effect. And here's the, why didn't it keep that? Here's the sums of squares for each of those. Here's degrees of freedom. Here's mean squares. And then here's the F. And there's the significance of the F. So that gives us everything that we need. I didn't highlight the denominator information yet, but that gives us everything that we need for our numerators. And here's the information that went into our denominators. And with this information, you would be able to fill in your source table. Okay, so we'll go ahead and let me just go ahead and go over here, and we could go ahead and start writing out our results for this. So what we're going to say, because it's a two-way analysis variance, we have to have 3 different conclusion statements there, and I should have pointed this out. All 3 of these are greater than 0.05, so nothing significant. So we're going to say there is not a significant effect of religious importance on, I'm just going to call it, if you don't mind, sex okay, just to save myself some time. And then I'm going to put in, and I actually pre-typed this just to save a little time. So I'm going to put in the different values that I actually found. So F with 3 and 502 degrees of freedom equals 0.56, P greater than 0.05. That's for religious importance, right? Then we're going to do male presence, and we're going to come back over in here and get this data. So for male in the house, you see there's the 1, and you still use the 502 degrees of freedom, that's the denominator. The F value for that is 1.15, and that also P is greater than 0.05. And then you also need to say about the interaction. So you say the interaction is also not significant or non-significant. You have the same degrees of freedom in the denominator, 502. You have 3 degrees of freedom in the numerator. F is 1.39, and the P is greater than 0.05. Okay? And the only other thing I guess that I'll show you, there's no point in looking at all these means and the post-hoc comparisons because everything was non-significant. I like having the plot because it helps me really to think about sort of what I found and what it means. Everything here is non-significant, so in that sense, I'm not really learning anything by looking at this. But if they had been significant, then obviously the plot is what really helps us in terms of interpreting our findings. Okay, the next thing that we need to do is to look at, and I'm going to let you do number 9 on your own for practice. We're going to look at questions that require regression, okay? And so the way we know that they require regression is going to be by the language in the question itself. So this question says, at baseline, does the child's view of how much support time his mother spends, how much time his mother spends with him, which is called time with mother at baseline, predict his views on the sex OK variable, okay? So time his mother spends with him is continuous, sex OK is continuous, so that means we're going to use regression analysis. And regression, we're finally going somewhere new, is down here, okay, regression, and then we're going to come over here and we're going to choose linear, which means that we're expecting that the relationship between the two variables is going to be linear, not curvilinear. Okay, so we click linear. Now we just need to find these variables to put them in. So sex OK is right here, that's the dependent variable, and this was written funny, but it ended up being that I wanted to know about time with mother as the independent variable. And really, you don't need anything over here when you're doing simple regression. You don't need any of these options, so you can just go ahead and click paste, go to your syntax window, and hit run. And as you know, when you do regression, you're going to end up with, again, data that looks like an ANOVA, and that's what you're going to report. This model summary is very informative because it gives you the Pearson correlation, and it also gives you the R square, which is the amount of explained variance. All right, so that's information that APA requires you to include in your conclusion statement. And then you're just going to look here at the ANOVA, and you're going to be saying, here's my numerator degrees of freedom, my denominator degrees of freedom, my F, and my P. And that's what you'll be reporting, of course, in your sentence. And that ANOVA table actually looks exactly like the ones that you've worked on your own class. Okay? And then when it's significant, then what's fantastic about regression, the best thing about regression, is that you get to come over here and you get to create a prediction equation. And so if this is significant, then you're going to come here and you're going to use this data to write out what the actual prediction equation is for how you can use time with mother to predict their views on whether or not having sex as a teenager is acceptable. Okay, so now we're going to go back over here so that we can start writing up these results. Okay, so I'm just going to paste this result in right here, and what it tells us in our, and what we make of the statement in our results is that the time spent with the mother is significantly predictive of views. And then we put F with 1 and 508 degrees of freedom equals 7.64, P less than 0.01. And then the next thing that we want to do, of course, is we want to say, okay, and what is the nature of this relationship? What does this prediction equation look like? And so we write this in, and it says the prediction equation indicates that spending more time with his mother is predictive of less approval of sexual activity. And you can see that here because you use this data to create your prediction equation. So Y hat is negative 0.046. Here's the B value for time with mother, negative 0.046, times time with mother plus the constant, okay, 2.72 or that should really be 2.73. And if you all can't figure out how to use the equation editor in Microsoft Word, feel free to just write this in by hand before you submit your assignment if you need to do it that way. Or you can just write it out more in words if you need to. You don't have to go to any extra trouble. So what this is saying is that as time with mother increases, their views of the acceptability of sexual activity as a teenager go down. And so if you knew that they spent, I can't remember what metric that was in. I don't even know if I can figure it out by looking at it. Yeah, I don't know what metric that's in. And in fact, it may actually be a categorical variable that just is